We've not evolved in that much in 10,000 years. The stressors that are upon us now, that's the mismatch. The mismatch is what this body evolved for. The classic example is food. So if we go back 10,000 years ago, although we're cooking meat, food is a precious resource and one needs to be able to get it all the time and store it. So it's a real advantage when you get too much in times of plenty. Eat as much as you can, you put that on as body fat, and that will sustain you in times when there's less around. And then what that leads to is a human that's evolved to always go for fattier, sweeter, high calorie loads, because it's an evolutionarily sensible thing to do. The mismatch is today I have more food than I could ever need, but because we've evolved to seek that out, that leads to people overeating in a world of plenty.
Welcome back, everyone. Today we're going to continue our conversation about human evolution and how an understanding of human evolution can help us understand mental health problems, psychiatric issues. And with us to continue this conversation is Dr. Derek Tracy. Dr. Tracy is the Chief Medical Officer at the South London and Maudsley NHS Foundation Trust, and we're very happy to have him here with us today. Derek, thank you so much for joining us.
Pleasure.
I'm aware you wrote a couple of chapters in a book about evolutionary psychiatry. And the first question I'd like to ask is, if there were some things about human evolution that you'd love people to understand that perhaps aren't so obvious, what would those things be?
I think what an amazing story it is. It's sometimes described as the most incredible story ever told. And how the reason I got interested when I was, I guess, a medical student or a resident doctor, I found neuroanatomy quite mechanistic. There were pictures of brains and line drawings to them. It was a task by memory rather than understanding why do we have the brains that we have. And I think what I would like people to understand, if one takes an evolutionary approach, so we can go back hundreds of millions of years and think through how neural systems emerged in response to their environment and why different parts of the brain were selectively chosen for, it makes sense. It makes sense why we have the brains we have, from very primal parts that control organs and help them function to parts that drive basic behaviors like appetite and reproduction, midbrain structures that drive emotion and memory, and then the prefrontal cortex. It's a logical sequence. So the evolutionary approach of the brain is a really helpful, logical way to understand the brain. And I think then the second part is, if we think about what our nervous systems evolved for, and then we think about what's sometimes called a mismatch of the environment in which we live today, it helps us conceptualize some of the struggles that we have as humans. So it's a slightly fantasy perfect model to think about. If we think back about a brain that evolved from maybe 12,000 years ago, before the agricultural revolution, and then we place ourselves in Trafalgar Square in central London, we can see the potential stresses and strains on a brain.
Yes, and we're definitely going to talk about this concept of mismatch later on, which I think is fascinating. But first, what do you think distinguishes, Homo sapiens from other humans, but then also other primates? Why is it that we became the dominant species on the planet?
It's not fully clear, I suppose, and there are lots of different hypotheses. So, and indeed, my prediction is the next 10 or 15 years are going to be really exciting. I think we're at an incredible point in what's called paleoanthropology, which is the study of humans and our origins. Even in the last couple of weeks, there have been really interesting finds in China. A lot of the work has been Eurocentric, and that's a research bias going back a couple of hundred years, where a lot of the scientists were Europeans. And there was, for example, a drive towards understanding Neanderthal, because that's what we found. And there's a really interesting hominin called Denisovan, which is largely Asian in origin, that we're trying to understand much more about now as more data come through from Asia. If we go back maybe 300, 400,000 years ago, there were several hominins at the same time. So human species. And I think what we had until maybe 20 years ago was a very false linear path. You're probably familiar with that t-shirt or poster, and it shows an ever-evolving hominin going ever more upright. Normally at the end of it, there's a joke put in. That linear trail is quite false. And what we often think about is what's sometimes called a braided stream, or a bush model where it's all different hominins interbreeding. So they diversify and they interbreed back. But if we go back about 200, 300,000 years ago, there were multiple hominids at the same time. It's hard to be certain exactly who was where, although we've put reasonably good data, and they were interbreeding. So the major ones we sometimes think about were Homo sapiens that were evolving in Africa, Homo neanderthal evolving in Europe, and Homo denisova evolving in Asia. Now, in some ways, they're still with us now. So I'm of European heritage, so I'll typically have 3 to 4% Neanderthal genetic makeup. So Neanderthals are alive. They're in me and they're in you if you're of European heritage. And if one is of Asian heritage, you'll have between 0.5 and 5% Denisovan DNA. So they never fully disappeared. We can try extrapolate differences between the species. It's not entirely clear. It's certainly true and seductive to link the emergence of Homo sapiens out of Africa 50 to 60,000 years ago with the demise of Neanderthals in Europe. And there is a temporal link. But that could be lots of things. So the obvious thing that jumps to mind is, did we fight them? And there's not particularly a huge amount of evidence. So there's not evidence we were necessarily stronger. In fact, they're quite a stocky build. There's evidence to suggest they might have had a bit of a population bottleneck, being declining anyway through successive ice ages. There might have been infections. We can think about when Europeans first went to the New World and brought with them flus and colds. And then maybe we did outcompete them. We certainly bred with them. So it's difficult to be certain. There is some evidence if we look at some of the tools that Neanderthal made, some of the needleware and the knives, they were less fine than some of the Homo sapiens work. The artwork was less abstracting and symbolic than some of the Homo sapiens. So historically, there's been a proposal that Homo sapiens might have had a more developed prefrontal cortex, were better able to deal through the orbitofrontal cortex in terms of abstract thoughts, what's called nesting of ideas. But actually, over the last 5 or 10 years, the data has really been narrowing between the two species to the point that it's not really clear. There were definitely differences between them, physical differences. It's quite hard to be certain from a cognitive point of view, but the older idea of a rather brutish caveman for Neanderthal is not really clear. I suspect it's probably a combination of things. I think the data look like there were definitely physical differences. There were possibly cognitive or social differences too. And then there were environmental issues. And then one could throw in random things such as infections and so forth, jumping between populations.
In his book Sapiens, Yuval Noah Harari, really what he zones in on is language and then the ability of Homo sapiens to have a shared story and to use that story in order to unite in unprecedented numbers. So, for example, we can come up with a story about a car brand called Toyota, and under this car brand, you can unite hundreds, thousands, hundreds of thousands of people all working towards the same goal. Do you think that's a valid theory? Is there evidence for it? Could it be that Neanderthals also had this capacity?
It's possible. I would point out, to be slightly provocative, that particular book is not without controversy in individuals within the fields. I've no fixed opinion on it, but it's not one that's always fully regarded by those who have scientific backgrounds in the area. I'd probably defer more to some of Robin Dunbar's work, evolutionary psychologist. Talks about a thing called Dunbar's number. This is not totally dissimilar to what you're saying, and this talks about the complexity of the social network in which we can evolve. So at very crude levels, we can think about layers of an onion. So the closest layer to you is your immediate family, then maybe your best friends, going further out to a network you're pretty close to, and going out to a tribal level. And one's orbitofrontal cortex and other parts of the PFC are involved in the ability to contain that type of information online, to hold those networks in place. What's definitely true between us and other hominids, so the great apes, is we can do this much more than they can if we compare to gorilla, chimpanzee, bonobo, and so forth. Now, what's been extrapolated, and this is complicated, so one could do things such as take skull casings and the castings from Neanderthal and so forth and look at different sizes of different parts of the brain, so they're not always equal. Total volume might be similar, but they can be disproportionately bigger or larger in or smaller in different areas. There's a hypothesis that perhaps Neanderthal wasn't able to have as large a social network, and that one of the advantages of Homo sapiens might have been that greater tribal group. So it's not necessarily that I'm cleverer than you, but maybe my group is larger and my network is larger than yours and your family. And that gives us a competitive evolutionary advantage. Now, what I'd say is this is inferential. There are data sets behind it, but there's a lot of extrapolation and there's a lot of uncertainty about that.
And in terms of the brain growth of Homo sapiens across time, do we have a clear understanding of what are the factors which catalyzed brain growth in humans?
Yeah, I think one of the big things that there is a thing called the expensive gut hypothesis, and the change in our diet maybe about 1 million years ago, where we moved to eating cooked foods. And again, this is not without debate. If we think about what we know, the brain takes about a quarter of our metabolic intake. A lot of calories go to keep that going. So from an evolutionary point of view, one doesn't just grow a big brain, and evolution doesn't look into the future and say, but that will be helpful 10,000 years from now. There's an immediate survival element. Most animals, from T-Rex to pandas, they're not of particularly big cortices. They have them big enough because of the energy they take in to be able to grow a bigger brain. So if a mutation occurs that helps support larger cortical growth, one needs an animal that's got enough food intake reliably to sustain that. Because the converse is, if there are mutations, which is what happens, that lead to brain growth, that needs more energy. And if you can't support that with food, then that animal's going to die. At the time, a lot of our energy, the other part of our body that takes a lot of energy is our intestines. And it's for the same reason, because of all the peripheral nervous system that goes to it. So you're probably familiar with that old phrase about there are as many neurons outside your brain going to your GI tract as there are in your brain. Now, of course, in your GI tract, they're not coordinated in the same way. They're going around your GI tract and helping with peristalsis and so forth, helping movement through your GI tract. The reason they take so much energy, it's maintaining neurons in a state where they're ready to depolarize. That takes a lot of energy just to do that, either in your brain or in your gut. Going back 1 million years ago, like lots of quadrupeds or other animals or the hominids, a lot of energy went into supporting that GI tract. Anything that can reduce that need, that'll release energy. So if we don't need as big a GI tract, and then also anything that will give us more energy. So those two things. And the tipping point for us, it's argued, was cooking food, particularly meat. So if you cook food, it does a couple of things. Now, of course, in the first instance, what people probably did was early hominins found cooked food. If you think about a forest fire, which they're pretty common in uncontrolled environments, animals would learn with time. If you go to where the fire is, you find carcasses. And so it's just a practical thing. And so probably going back again a long time, animals learn to follow smoke and to follow fires and then to eat cooked food. And my guess is, because this is how we are today, it tastes better when you eat it. So they enjoyed it. It does two things. One is if you cook it, it sterilizes it, which is helpful. But actually the main gain that one gets, if you cook meat, you release about 40% more energy. It's quite hard to metabolize raw meat, so you don't get as much energy out of it. And that seems to have unleashed, going back to Homo erectus, is the animal that was certainly doing it. And it went from an animal that could track fire to an animal that was able to manage fire, perhaps you can get animal fecal material that's dried and use that to keep embers going over long periods of time, to a later stage where we could manufacture fire from flints and learn to cook food. So we went from opportunistic to being able to cook food on a regular basis. And when you do that, then you have an animal with that intake. One, it doesn't need a GI tract to be as long, because a longer GI tract is primarily for vegetative food, not for meat. So you can lose energy requirement there. And two, that energy source from the meat means that mutations for brain growth can now be supported.
Yes, that makes a lot of sense. In some corners of the internet, you can also learn about what's called the stoned ape theory, which is the idea that early humans finding natural psychedelics in the landscape might have also influenced brain growth and development. Is there any truth or evidence to that, or is that pure conjecture at this point?
From my point of view, it's conjecture. I've not seen anything to support it. I think there are interesting hypotheses about shamanistic cultures. Well, I mean, there's an interesting sociological debate about psychoses. And a lot of what we box in today and say, this is normal, this is not normal, throughout human history, different cultures interpret it in different ways about vision seeing or being able to communicate in different ways. So that shamanistic culture where it was valued, if I think, is it possible over time that different hominins ingested psychedelics, enjoyed it, or it added to experiences? I think that's probably likely. I think what's really interesting as a species, we're drawn to difference. So one of the debates is about how psychoses are sustained. They're such debilitating conditions for many people. They come on quite young, so they come on at an age when people are typically reproducing. And what is it about psychosis that continues and there isn't a genetic selection to get rid of it? And there are lots of different arguments one could go through, but certainly differences in thinking and different approaches. And there's an analogy here with taking psychedelics. We are attracted to people who think differently. If you think about your favorite artist or musician or poet, I hope you're not going to tell me it's someone who's quite middle of the road, and you're going to tell me about someone who helps you see the world in a different way, who says things that maybe you felt and never said before. So there's an attraction to it, and I can see the attraction of the model that psychedelics therefore might have helped with an evolutionary process, but I don't see evidence for that part. So I don't see an evidence for that driving any evolutionary processes.
Yeah, and I think I agree. One of the most striking findings about psychedelics I'm aware of is my understanding is there is a study which suggests that psychedelics use can increase someone's openness to experience. So a personality trait associated with intellect, creativity, seeking novelty, etc. And that psychedelics use can increase their trait openness by one standard deviation, which is pretty significant. But I think I agree with you that there's still quite a few leaps to be made before we arrive at the conclusion that psychedelics are meaningfully catalyzing the evolution of humans.
But just to jump onto your point, you've also raised an interesting issue about, as you know, there's a contemporary evaluation of psychedelics in terms of antidepressant use and some of the work through them, which is there's interesting data coming through. I think the question isn't so much are they good or bad for depression. The question is probably going to be when and in whom do they work as a subtype of depression. But one of the things they may do that folk have explored, and this is not my primary area, but is whether or not that openness to new experience about reframing of cognitions through different lens may be helpful. And that certainly feels plausible.
Yeah, we had David Nutt on the podcast last week, and that's his contention, that it is that psychedelics can provide that window of opportunity where obviously in combination with some kind of therapy, people can rethink things and therefore behave differently. And therefore it gives them a window of opportunity to get out of these very fixed mental patterns that often keep people stuck in something, say depression or anxiety. Before we go on to this mismatch idea, which I think I really want people to understand, looking again at the timeline of Homo sapiens, I really love people to understand how recent is civilization? How much of human history have we had like agriculture and civilization versus how much were we nomadic hunter-gatherers?
Well, of course, the word civilization is culturally loaded, meaning developed versus undeveloped. So lots of baggage with it.
Sure.
Homo sapiens, best data suggests at the moment we're about 300,000 years old as a species, although there's these really interesting data sets coming out of China, which are really throwing all our presumptions in the air of findings of hominins about 1 million years old, which don't really fit with our current model. But anyway, our typical model is a Pan-African emergence of hominins over the past 3, 4, 5 million years. Some of them emerging into Europe quite early on, so Homo erectus, possibly Homo habilis going out, and then you get this subspecies emerging into Europe and Asia with as mentioned, Neanderthal and Denisova. But let's go with the best days, about 300,000 years as a species of Homo sapiens from an ancestral species. And it's still debated what that ancestral species is. Now, one assumes over that 300,000 years, this ongoing evolution as a species. So that would have been an early Homo sapiens. What we don't know is how different or how similar to us were they. But here's a thought experiment. For those of us who are non-sub-Saharan African origins, so that's a lot of the world, we all came from a population that left through Northern Africa about 60,000 years ago. So that means people from Papua New Guinea and people from Sweden, just two groups who look culturally quite different. They have the same ancestral group going back only 60,000 years. And so one can see, for example, there's huge variation in culture and in phenotype, from skin color to hair texture to average height and so forth. It's only 60,000 years and we see massive variation. And if we take that Homo sapiens is 300,000 years, one can imagine there's been lots of evolution on the way. So a question then is, how much change has occurred in that time? It's not fully clear. Now, there's an interesting thing that happens about 60,000 years ago. It's sometimes referred to as behavioral modernism. And we suddenly see an increase in symbolic art around the world, and then more complicated jewelry and beads and so forth. Now, a hypothesis that exists, but this is debated, was whether or not something happened at that point. Were we evolving? And about 60,000 years ago, one hits a really critical change. And the very seductive argument is this is where language gets complex. And that allows us to think and talk in metaphor and symbolism and so forth. And then it's been work around the FOXP2 gene that you might be familiar with, which seems to be a significant mutation associated with language. Or to flip it the other way around, people who have problems with that gene sometimes have difficulty with enunciated speech. That's possible. So one argument is about 60,000 years ago, suddenly something happens within a population of hominins and we become much more complex. I'd argue, my read of it is that's seductive, but probably not as compelling as more recent data that says actually what happens around 60,000 years ago is more gradual. We get sufficient population density that ideas can be sustained within a population. So let's say I'm developing new bead technology. Well, I need to pass it on to my children who go travel to another neighboring village. And there's an argument that before 60,000 years ago, we were too spread out. And maybe what's happening is we're gradually getting smarter, or maybe we're quite similar, but then we reach a population density that our ability to share ideas grows. In the same way, over the last 25 years, through the internet, our ability to share ideas has massively, you get this exponential leap. There's no change in humans. We're not sure. So there's certainly a massive change in our population about 60,000 years ago through this increase in what look like trade networks, beads, more sophisticated goods, and so forth. And then there's a spread of different cultures throughout Africa and Asia and Europe over the last 30, 40,000 years ago. You see them increasingly complex in terms of the goods and that we find in graves. And of course, this takes us to about 12,000 years ago, where we get the Neolithic Revolution. And we move in parts of the world from being hunter-gatherers to moving into agriculture in different ways, from being pastoral farmers to other types of agriculture.
So that's a big deal. 12,000 years ago, we start to settle more, become less nomadic, and develop agriculture.
Yeah, and then, of course, that has massive changes. So if we take, it's sometimes put as a cutoff point, it's a bit arbitrary, but if we take humans perfectly evolved for life just before then, so we were certainly well evolved to be those hunter-gatherers. And then through domesticating animals and learning how to plant crops, suddenly life is easier. One stays put, grows all this around us, and then we get the emergence of towns and ultimately cities and civilizations in a way that we never had before, because prior to this, one has roaming bands. They might settle, but they're liable to follow animals or herds around and hunt, and that changes human behavior. Not the brain, but how we interact with each other, how we access food. Trades emerge. So my job isn't just to hunt and gather. Maybe my job is to make metalware, and then I can barter with people. And we see the emergence of economies, and it's changing behavior with the same brain.
people become specialists rather than generalists. And like in hunter-gatherer societies, most people are hunting and gathering. Now in modern society, people do all manner of different things, and typically one person does one very, very ultra-specific, ultra-specified activity.
Absolutely.
How much do we understand about what hunter-gatherer life was like? And are there modern hunter-gatherer populations we can look at?
There are. I mean, I think one thing to say is it's very easy to, and I'm prone to this, to draw up a slightly fantasy perfect model of a group of humans perfectly adapted to their life. And what we often pick is perhaps what one might see in parts of sub-Saharan Africa with hunter-gatherer populations. But the thing that defines Homo sapiens is our versatility. And those populations are really quite different. So a counterexample would be an Inuit people up in northern latitudes who are hunter-gatherers in a very different way. They're not persistence running and hunting down gazelles. Their specialization is through different types of fishing. So I think part of my re-education about hunter-gatherer populations is I think one can fantasize and draw very perfect people doing a very similar thing. So one is life was hard. So you break your leg and you're a hunter-gatherer and you're doing persistence hunting. That's a really life-threatening problem, potentially, although we could care for each other. Like, it was a dangerous environment to be in. The infant mortality was high. And then the other thing is to say that's geographically really different. Hunter-gatherers in one part of the world would be very, very different to others in terms of the type of food they got and the terms of types of lifestyle. So I think it's probably a mistake to look for a single type of lifestyle, but certainly folk who are very active, people who are typically following food sources around, and people really marked by ingenuity in how they would catch them and developing fishing nets. I mean, it's incredible what people were doing tens of thousands of years ago.
Yeah, so different populations can look very different at a glance, but perhaps there are some commonalities underneath. The strong sense of community, I imagine. Everyone is involved, or most people will be involved in very immersive, dynamic problem solving. Always problems to be solved, problems which are very concrete. How do we avoid the next weather storm? How do we get food? How do we solve the water shortage problem? How do we deal with the neighboring tribe? Everyone's very engaged.
I think so. Yeah, I think a couple of things. One is that metacognitive ability. So the ability to think about thought, the ability to forward plan, the ability to think into the future, to think about things that hadn't occurred. I sometimes look at the old cave artwork that one can see on the internet and elsewhere, and they're different beautiful drawings. There was one always struck me. There was a human with a bird's head was one of the drawings. It goes back about 30,000 years. I can't remember which site it was from. If you think about that for a moment, a human with a bird's head, there's no such thing. There has never been a human with a bird's head. There never will. This was a species that could think about things that had never been and would never be. Their imagination could see into the future. They could foresee their death. They could think into their past. And then the other thing is that social network. It wasn't just one person. Alloparenting, grandmothers helping mothers raise their children. Chimpanzees, on average, can have an infant every 7 years. Humans can do it much more frequently. I think it's 7. It might be 3 or 4, because they have to raise the infant, then go on to the next one, because they do it by themselves with limited support. By having family network models and being able to pass typically to sisters or to mothers, a mother's mother, one can have that support and grow networks in very complex ways.
Okay, great. So now that we understand a bit about human history and a little bit about what hunter-gatherer life could have been like, could you introduce this notion of mismatch, and how does that help us understand some of our predicaments and modern problems?
So if we take, although I said it's a slight fantasy model, but if we go pre-Neolithic, so before we have these settled communities, and we think about an animal relatively well evolved for that hunter-gatherer lifestyle, albeit that's not an easy lifestyle. And then we transfer it. And so we've got an animal that will learn to respond to stress and emotions and pressures around it, but in a way that one is anticipating in that hunter-gatherer lifestyle. If one then transposes it to, I'm just going to pick Trafalgar Square in central London. I don't know how it'll resonate with your audience. We now have a very different set, and we've not evolved in that much in 10,000 years. The stressors that are upon us now, that's the mismatch. The mismatch is what this body evolved for. So if I met a human from 10,000 years ago, we'd speak a different language, but we're otherwise pretty similar. So I could survive in their life, although I probably need to get physically fit. They could come into my life and survive it, but we both would face struggles in a contemporary world where we haven't quite evolved for those issues. The classic example is food. So if we go back 10,000 years ago, although we're cooking meat, food is a precious resource and one needs to be able to get it all the time and stored. So it's a real advantage when you get too much in times of plenty. Eat as much as you can, you put that on as body fat, and that will sustain you in times when there's less around. And then what that leads to is a human that's evolved to always go for fattier, sweeter, high calorie loads. If you give a chimpanzee a choice of raw potato, mashed potato, roast potato, they will go for the high fat one, and humans do exactly the same. We know, and it does taste better. If I do that to you, if I give you a bowl of potatoes, mash, or I give you chips, you'll go for chips unless you cognitively decide I'm on a diet and I choose not to. We always go for that rich, calorie-laden food because it's an evolutionarily sensible thing to do. The mismatch is today I have more food than I could ever need, but because we've evolved to seek that out, that leads to people overeating in a world of plenty. And one can go from that into mental health analogies. So the having stress responses are good, being made anxious by different parts of the environment are good, being made paranoid, these are normal feelings. But if we're in a world that is perpetually doing this to us, so the example I sometimes give when I'm teaching to my students, because it's stress, I don't want to stress them a bit, but I suppose to joke with them a little bit, they haven't evolved to sit in a lecture theatre in King's College London and do exams all day, or for me doing in medical school, or doing the things I love my job, but there's a lot of pressure with it. And so that mismatch is between what the brain and body has evolved to do and the world in which it finds itself. And that is believed to underlie an awful lot of our physical health and mental health problems. Again, if we think about physical health and activity and we're aware, get your 10,000 steps in a day, because that's what we used to do. Although I would add, there's no actual evidence for 10,000 steps. That was based around a sales technique. Yeah. We used to walk a lot. So without that, then we have problems with blood pressure, with hypertension, with diabetes and so forth. So that's the mismatch.
So I guess, especially with the example of food and physical activity, what you're really saying is we're victims of our own success. We love food. We have these instincts to binge on tasty, high-fat, high-calorie food. And then we create supermarkets, which allow us to get that food really cheaply. We love not having to expend too much energy because that could have been dangerous in earlier times in our history. And now we've created an environment. We've created cars, for example, so we can expend very little energy and travel huge distances. And we've kind of, in some sense, maybe this is I'm being a bit hyperbolic, we've entombed ourselves in these technologies, which are then surreptitiously kind of taking stuff away from us. For example, because we're not moving as much or lifting, our muscles get weaker.
Yeah, absolutely. So I think a lot of hunter-gatherer populations would look in bemusement at someone who's just running for its own sake. They would, if they weren't hunting an animal, they would sit. Why would you do that? Now we have to cognitively override and force ourselves to do it. So the instinct, which is a correct one, is when things aren't busy, rest. If there's food there, eat it. They're really sensible drivers within us. What we need to do now, though, to your point, is I can just get in the tube, I can drive a car, I can go in an airplane. And so our lifestyle, entombing is not a bad word. One has to use the PFC and say, I choose to manually override this, and I know I need to get some steps and get some exercise. And okay, I can have another chocolate donut, or I can go for a salad tomorrow. And we have to use our prefrontal cortex to make an active decision that is trying to push against those very primal drives.
And now it seems the people who can really delay gratification, the people with those really strong prefrontal cortexes, if you like, who can overcome those drives, tend to be the most successful among us, at least in terms of wealth, longevity, stuff like that. We're really living in a world that seems that is selecting for those kinds of traits, perhaps not selecting in a kind of reproductive sense, because those people might not necessarily have more children, but in terms of like accumulating success across life.
Maybe I would challenge it a bit. I think there's luck and serendipity are parts of it, and I wouldn't wish for a world where there's a overdominance of what we might call type A traits. I think there are traits that help one succeed in a typical, maybe Western business model about a focus, drive, attention. I think there's a mismatch if society goes too far that way too, and we lose some of the, maybe a contemporary phrase being neurodiversity, but some of the breadth of emotional intelligence. I think a problem in contemporary society, it doesn't reward all different types of intelligence. And to go back to different types of thinking, creativity and artists and so forth. So maybe like your word civilization, the word success is a loaded one.
Yeah, it depends on your definition of success, of course. I guess I'm thinking of success in conventional terms, the accumulation of money and status, yeah. But that's important.
It's important, but interestingly, how it correlates. So there's that phrase, best things in life are free. So money can't buy me love, as the Beatles said. And I guess there's probably a question about how it links with happiness. And maybe, in fact, one of the mismatches today is searching for that proposed success at a cost of emotional satisfaction.
Yeah, I guess what my concern is that then those people who can really delay gratification, accumulate wealth and status, often become dominant in political and economic ways. I'm thinking of the Elon Musks and the Mark Zuckerbergs of the world, who now command amounts of wealth comparable to small countries and have a huge amount of ability to influence the world disproportionately.
Yeah, maybe again, I think I'm not sure I would necessarily associate politicians with people who can delay gratification. And I think one could challenge, I think there's a danger with people like Musk and Zuckerberg, that low number of hyper successful individuals. The classic story, the seductive one, is the person who the quasi genius who left a typical path to set up a business. But there's 1,000 people who left university, set up a business and failed. So I'm just cautious about drawing conclusions from very low numbers of individuals.
Getting back to mental health, you mentioned neurodiversity. So one thing I'm concerned about is something like ADHD, say, where you see people who have diagnoses of ADHD, and especially in the milder end, where they clearly have difficulties and have certain levels of impairment in terms of going about the tasks of modern life. But they also often describe strengths, like the ability to do hands-on tasks really well, to manage to do sports really well, to manage environments where there's a lot of dynamic tasks, again, rapidly shifting from one task to the other. And that makes me wonder how much of this like milder form of ADHD is less of a disorder per se, but a result of the mismatch that we've described.
I guess I'd start with some caution, because people listening to this may have ADHD or autism spectrum disorders, and this is not my area of expertise. I'm coming in here on a somewhat speculative basis. It seems to me plausible if we take most traits. So if we're talking about neurodiversity, we could think about attentional processing, and then we could think about things like autism spectrum disorder. One typically gets a bell curve that we all fit somewhere on that. And then some people have more difficulty, or we could take anxiety as a spectrum as well, or paranoia, or any introversion, extroversion. We could take traits, and we can again take that bell curve. So most people are towards the middle, and then some people are towards either end of that as we get down to the tails. It's sometimes the case that people towards the tails can have more difficulty in different environments. But I think there's always been that spectrum. Now, one of the questions going back to the mismatch is, do contemporary lifestyles contribute to that? And I think that seemed reasonable. So if one has difficulty with attentional processing, and we were to think about, well, how would we make that worse for a young person? We'd probably design a classroom, and because that just feels like a really bad place to put that person. So I think there's something about our contemporary environments can make things worse. If we take that shamanistic model going back 500 years ago, I'm speculating, but maybe to have psychotic thoughts in some environments maybe were less problematic, because maybe people were less disturbed by the idea that someone heard a voice that might have different cultural or religious connotations. Simon Baron-Cohen, who's written a lot about autistic spectrum disorders, talks about an autistic brain being a way to help, a regulator of the world, a systematizer, and part of a Homo sapiens need to put logical systems. If A, then B. So one could see the stars in the sky at night and a comet, and then maybe there's a change in the weather, and people are beginning to join these dots. And that, again, if one takes that as a bell curve, that maybe some people are going to have more difficulty or less, but the breadth of those traits is probably helpful to the species more generally.
Now that we have an understanding of evolutionary mismatch, how that might contribute to some modern problems, I'm curious, how does this filter through to your consultations with your patients? Does it influence how you talk with them about their problems, what you might prescribe for them?
Yes, it does. I bring this in relatively frequently. I think it depends, as all things do. It depends on the person and the consultation, the problem. It depends on their internal models or what they want to talk about and so forth. But I find this often a helpful way to frame it. This might sound an unusual thing to say. One of the things that appeals to me about psychiatry is realizing the shared vulnerabilities we all have. There's none of us so strong that a phone call at 3 a.m. isn't going to shake our lives a lot, and none of us so weak that we don't have lots of strengths. I draw something. I draw a sense of shared humanity with people with this. We're all pretty vulnerable, and I think sometimes talking through that model about what we're like as people, how we try, how we do our best, how we struggle in the world around us can help. I mean, sometimes, of course, mental illness can come pretty much out of the blue. So we've got that complex gene-environment interaction going on most of the time. And sometimes it doesn't make sense to someone to go through it that way. But I think a lot of the time it does if we think about someone's lived experience in a world around them, different physical or psychological traumas they've suffered, how they're trying to do their best despite that. So personally, one, I find it helpful to me as a psychiatrist, thinking about who we are and why we have the brains we do and how we struggle with that. And two, I do find it helpful to bring that into the consultation room.
Yes, I think like you, I also bring it in quite frequently. So quite often I'll be talking to a patient, for example, that spends most of their time alone. This is increasingly common now and only really possible because we have access to certain technologies. Like if we didn't have laptops, we'd have to be speaking face to face or not at all. And so a lot of patients don't have that framing, as you said. They don't necessarily think, okay, what are the necessary or at least important ingredients for a satisfying human life? And if we looked at our hunter-gatherer past, we could say with reasonable confidence that one ingredient might be spending a lot of time with people and having rewarding relationships. And so thinking like that will often influence me to say, hey, if you're spending most of your time alone and you're feeling depressed, that might be a very natural reaction to that situation. And so, yes, there's a number of different interventions we could think about. If you're feeling depressed, we could consider an antidepressant. But I think we should also strongly consider getting you around people more often. I think that's very likely to help you with your mental state. Obviously, it's not a or, but it can be an and depends on the individual. But it's interesting that patients are often quite surprised to hear their doctor recommending that. I think society often conditions people to expect that doctors prescribe drugs, and they don't really expect psychiatrists to give life advice. But with this framing, these kinds of interventions, spending more time with people, having fulfilling or meaningful work, dealing with certain stresses, which are very unique and modern, to me, they seem like natural interventions and which are very often quite powerful for people.
Yeah, I think it can help frame it. Again, it won't always work. It's not always right for some, but I think as a principle, it can help frame ways we might look forward and manage things. And of course, for an individual coming in with any mental health problem, they have the strength, I guess, of the depth of their own personal experience, or what I guess we'd call lived experience or expert by experience in contemporary parlance. But what you don't get the breadth of having seen multiple people. So the advantage from a clinician's perspective is having seen this lots of times in different people. Everyone will of course be different, have their own unique story. So whilst we won't have, and some people have both the clinician and have been the patient. So while the clinician doesn't have that lived experience of that person, they have the breadth of having seen variations on this in different time frames. And that can also help normalize. Because I think if you come in, you can go, well, is this just me? And do other people cope? And is everyone else fine? You think, well, no, it's not just you. Lots of people will go through this. And one can help normalize, if that's the right word, because it can feel an abnormal situation, but one can help contextualize it also then in terms of think through treatments or problem solving has helped other people as well.
Yeah, I think that feeling that I'm suffering and my suffering is unique and everyone is getting along just fine is probably one of the most, it's extremely common, but it's so damaging for people to hold that belief. And therefore I agree, yeah, the ability to normalize mental suffering is such a huge part of what we do, I think, as psychiatrists. We're almost out of time, but just before you go, could you recommend any key thinkers or key books that could help people learn a bit more about evolutionary psychology or psychiatry?
So selfishly, I'm going to have to recommend a textbook that we wrote with colleagues. It's called Evolutionary Psychiatry. I'm one of the chapter editors. So that's a contemporary book I'd recommend. I always recommend the work of Chris Stringer if an individual is interested in paleoanthropology and human origins. And then I think Robin Dunbar is fantastic from an evolutionary psychology point of view. So they would be the three areas. Our textbook is very much the evolutionary psychiatry, the medical element of it. Chris Stringer is the evolutionary part of humans, how we came to be, and Robin Dunbar is the more sociological. He's an evolutionary psychologist. But to your issue about societal, cultural evolution, how we work in larger groups, I'd recommend his work.
Wonderful. I'll put a link to those in the description. In the meantime, Dr. Derek Tracy, thank you so much for joining us.
A real pleasure. Thank you.